capacitors. So you just get a bunch of small capacitors and you link them together as you would a bigger battery. And this is going to be able to keep your amps high or your voltage high without increasing your amps too much, because they're kind of connected. It's a lot of math that I don't really want to get into, which is funny.
Bruh, come on, do the math. What are we here for if not math?
I don't know that.
We have 8 minutes
I'll
left.
tell you the math real quick.
So, what this is going to be doing is this is going to be sending electricity to in our instance, we're going to be using a plastic rod, because that's the most simple way to do this.
Do you want to just link them to the WikiHow? Okay.
There's a WikiHow on
There's
how
a
to make
WikiHow.
railgun.
How to make a handmade railgun.
A pan?
You wrap your
Handmade.
wire around this plastic rod hundreds and hundreds of times, right?
It's more of a coil gun, but
And this is increasing your pressure, increasing your magnetism, and the more you do it, and then you wrap it over itself again, and then again and again and again, and the more and more you wrap it, the stronger and stronger your shot's going to be.
About 8
More
times.
power, it's going to take more pressure to force it down. So that's why you need these two high voltages. These usually run about 14 volts.
All right.
Around that.
and
You find these
because
in
it's
actually
fast
almost
acting, it's
everything.
high
Like, your
amperage.
standard camera will have a decently sized capacitor in it. Power banks have them because they're great for storing sudden bursts of electricity. So when that amount of voltage is applied to this coil, and a very interesting magnetic reaction happens, similar to Lenz's law, except for it's spooled in reverse. So while this will be hooked positive and negative up there, you simply change the polarity. And what that does, instead of slowing it down, it speeds it up rapidly. And you're shoving a whole lot of volts into this coil very, very quick. So your projectile is going to speed up this entire length in roughly 2 seconds, creating a not so fun projectile.
Well, I'd say it's fun. Personal opinion.
All right, so if the neighborhood power
Sure.
goes down, you can't blame me, right?
Right. Well, I mean, that's what the capacitors are for, you know?
That was a joke, by the way.
I know.
It wasn't a good joke, but it was a joke.
You
If
should.
you link enough of these together, you
shouldn't
can
do this.
actually fry your neighborhood's power grid.
Real quick thing about Lenz's law, a mistake I'm gonna be honest I made. The important thing about Lenz's law is to my knowledge, it's not actually attached to power. So there's no electricity involved, and that's what's so special about this phenomena that we.
Wait, it's not attached to power?
No, it's not.
Then how does
That's
the electromagnetic fields get?
Because there's a link between the magnet falling and because the thing about
The magnet moves the electrons itself because it is the
it's
field.
working in the opposite direction of the railgun, like Manuel was saying. We're putting current in, which creates magnetism that pushes that projectile forward.
You can use magnetism that is already there,
And
which
this
is, I lied, this isn't a railgun, this is a coil gun, but that is how rail guns work. So a railgun is not so simple. It has two.
You guys need some teamwork, fellas.
Explaining here, tag team, right? It ties greatly into railgun. You have around, let's say two big old magnets here, right? So with the coil, you're creating magnetism based on the rotation of the electrons and the movement of the electrons, and they're all densely compact in there, and they're pulling stuff, right?
So you'd be using big magnets instead of coils.
Big magnets instead of coils to where it already has that stuff densely compacted in here. So you just have a positive and a negative, and these aren't touching. But when something interesting happens, when a current is applied to these positive and negative, these magnets actually magnetize the electrons going through here. So it looks something. So let's say these are your coils, and you have your magnet down here. It actually magnetizes it somewhere similar to something like this. And you have your barrel here, and it moves your projectile along. So that's why it's called a railgun, because you actually have two rails.
That makes sense.
But it's not coiled up. So
It's it's the properties of the coil guns on each
the
side.
magnet is not the projectile. But
Yeah, it's the properties of the coil guns on either side that push it forward. But it's not a coil gun itself.
So
Yeah,
we'd be
that's-
using something like neodymium to like
Yeah.
power
Yes,
that?
exactly. Yeah.
Because
That's-
neodymium's like the most powerful magnets we got, right?
Right. The more
That's-
powerful the magnet,
Let 'em
the more
proceed,
powerful
let
the
'em
action.
Yeah,
Yeah.
that's also the magnet you want to use for this, because like I said, we aren't actually introducing any, the only energy we're really putting in is the gravitational potential energy. That's what we're putting in. Through Lenz's law, the dropping of the magnet, the magnet itself has a magnetic current, of course. That's how magnets work. And because of the magnet converting some of that gravitational potential energy into the current, which we can detect, and of course use with turbines and whatnot. The falling rate of that magnet decreases. So that's where that energy is going. Does that make sense?
Mm-hmm.
Okay. And then the opposite of this, just putting it out there, also shows how electromagnets work. So if you have say a nail, and then you wrap a coil around it, and then this is connected to a magnet. So the opposite of this, the nail, which obviously isn't normally a magnet, becomes a magnet because through Lenz's law, if you have a rotating current, you'll have a rotating magnetic field. Does that make sense?
The nail example only worked with
Iron?
iron is the best, but you can also use steel as long as it's low carbon.
Well, our steel's made up of iron.
Yeah.
It's
It's
carbon.
iron compounds that don't
Yeah.
have a
It's
lot
an
of
iron
carbon.
alloy.
Yeah.
Yes.
You can also use nickel. It's not going to work as well, but you couldn't use nickel.
You can use nickel, are you sure? Alright.
Yes, that's.
You want to get the metal thing? Like from Miss Lum's class? The electromagnet? Not now, but next week.
Maybe, perhaps. But we have to figure out how to throw more juice into it, because at the moment, it just kind of sucks something in and gets stuck midway, because it doesn't have enough voltage to push it all the way through.
Oh, no, I'm not talking about the... We can probably bring the coil gun, but we don't have a working
Miss
one.
Lum has a working coil.
Oh, okay.
We found them.
We
in-
should probably wrap up the meeting.
Yep. Alright. I feel like we got there.
Well, we can't.